49. When 2.5 grams of methane burns in oxygen, 125 kilojoules of heat is produced. What is the enthalpy of combustion per mole, so maybe I'll highlight that, per mole of methane under these conditions? Okay, so if we read just what the question is again, they're asking for what's the enthalpy of combustion per mole. So remember, whenever I see the word per, that means division. So it looks like I'm dividing something by something else. Let's look at what the units they want. The thing is that they're talking about enthalpy. And enthalpy is always a delta H. I remember this by seeing the H in enthalpy for H. And then, if I just keep running with this H idea, enthalpy is basically the amount of heat that is either being absorbed or released when you burn 1 mole of a substance by combustion. In this case, we're specifically talking about methane when it burns in oxygen in a combustion reaction. Now, just know, guys, that the units of delta H has a very specific unit. Delta H is always in kilojoules per mole. So, what we have to do is we basically just have to find the kilojoules, find the moles, and divide them. And that's what they're saying here. You see, it's the enthalpy of combustion per mole, dividing by mole. So that's basically what this is. Now, they gave us the first piece of the puzzle. They said that we were going to see 125 kilojoules of heat being produced. So I know the top number, 125 kilojoules. But now what's the mole amount? Well, they told us that 2.5 grams of methane is going to be burned. So how do I go from a gram to a mole? We know this, right? We so know this. We just got to convert. 2.5, 0 grams of methane. Now this is the trick. You might not know what methane is. You could either find it in the chapter of your enthalpy, but methane is CH4. So let's just do our dimensional analysis times by a ratio, throw the unit that you don't want on the opposite side. This was grams of CH4. So grams of CH4 goes on the bottom. Mole of CH4 goes up on top. And now a gram to mole relationship of the same compound is always the periodic table. So get your periodic tables out, guys, right? Remember, when we're using the periodic table, it's always 1 mole. So 1 mole equals whatever it is on the periodic table. So 12.01 plus 4 times 1.008, if we get the exact numbers. 16.042 I got roughly. Grams cancel out. We're going to get the mole value. 2.5 divided by that answer. I get 0.1558. And that's the amount of moles of the methane, CH4. So now here we go. Delta H equals, and maybe I'll just put it again, kilojoules per mole. So, they told us the kilojoules, 125. And then I'm dividing it by 0.1558 moles. And now there we go. 125 divided by 0.1558. Looks like 3 sig figs here, so 802 kilojoules per mole. Now, just know, guys, that generally combustion reactions are always going to be exothermic. Exothermic means that the energy that is being created is going to be released into the environment. That means when these hydrocarbons, such as methane or methanol or isooctane, when they burn into oxygen, there's going to be heat that's being produced that is going to be released into the environment. The environment's going to get hot. So in that case, because it's exothermic, and mostly combustion reactions are exothermic, this has to be a negative 802 kilojoules per mole. The negative represents that there is a release of heat. All right, so that now is the final answer. So what's the enthalpy of combustion per mole? It's a negative 802 kilojoules per mole. There's going to be a release of 802 kilojoules per 1 mole that's being burned in oxygen. Thank you so much for viewing the video. I really hope this helped. Let me know in the comments. Subscribe to the channel if you want to help us out. Thank you so much for that, and let's keep studying, all right? I believe in you guys, and, let's keep rocking and rolling. I'll see you in the next lesson. Bye-bye.